So we are done with annuities, solving for annuity future value, annuity present value, annuity payment, annuity interest rate, and number of annuity payments. Now we are going to look at the next topic in this chapter, perpetuities. Something perpetual, something that never ends, keeps going, right? Perpetuity is defined as a perpetual series of cash flows of an equal amount at fixed intervals. Basically, it's exactly the same thing as an annuity that continues forever. There is no end to annuity payments. Keeps going forever. Okay? Let's say we have a perpetuity with some repeating cash flow that keeps going forever, and we want to find the present value of the whole endless sequence of these cash flows. If we were to do it one by one, right, individual present values and add them up, we would do the first cash flow in the future discounted back by 1 year. So we divide it by 1 plus the interest rate, plus the present value of the second cash flow 2 years from today, or 2 time periods more generally from today. You take cash flow, divide by squared 1 plus r, right? 1 plus r to the power 2. Then you do the same for the third cash flow in the future, using the power 3 in the denominator, plus the present value of the fourth cash flow in the future, right? Where you use power 4 in the denominator, and so on forever. Where do you stop? You never stop. You should keep adding all those terms, right? So is there a way to simplify it? Yes. The simplest formula you will ever see in finance. The present value of a perpetuity is equal to the cash flow, which is repeating forever, divided by the interest rate. One thing you may notice is that this perpetuity present value formula gives you the today's the sum of all future cash flows in today's dollars, one time period before the very first one, right? So if it started immediately, then in this formula you would need to just put plus cash flow. So you would have C divided by R, and then you would add cash flow. But technically you can even call it a perpetuity due. That's something I sort of made up at some point. But the book doesn't even talk about anything like this. So this is pretty much, what the book says for perpetuities. The first cash flow is not immediate, but with a 1 time period delay, and the present value of that endless sequence is C divided by R. What would be an example of a perpetuity in real life? There are actually not that many real-life examples of perpetuity. There's something called preferred stock. So some companies have 2 different types of stock shares. One known as common stock, where the company would be paying dividends that are neither guaranteed nor of equal amount. So maybe today it pays a $1 dividend on each share, next time it pays nothing, then nothing again, and then pays a $3 dividend per share, and so on. So it kind of fluctuates and is not sort of regular. Preferred stock is another type of stock that exists for some companies. That's when a company promises to preferred stock holders a fixed dividend every period, usually every quarter, forever. Right? So as long as the company is around, it will be paying the dividend to the investors forever. And not just the dividend, it's going to be a fixed dividend. So it's the same dollar amount forever, which makes it a perpetuity. Let's look at what we are given for this problem. A company sells preferred stock for $80 a share. So we know the price per share. Its offered dividend is $3 paid once a year. The discount rate is 4%. The question is this stock priced correctly, or is it overpriced, or is it underpriced? Overpriced means $80 is way too much. It should cost less than that. Underpriced means $80 is too cheap. It should cost more than $80. So how about we use the information that we are given to calculate how much one share should cost. And because we are dealing with preferred stock, which is a perpetuity, we can simply find the present value of a perpetual stream of $3 using 4% for the discount rate. So $3 divided by 0.04, that's 4% interest rate in decimals, gives us $75 per share. So you should not be willing to pay more than $75 for getting back $3, at the end of each year forever, when the company generates a 4% return on its money every year. What do we know? We know that the shares are sold for $80, right? Which was given. That's way too much. That's $5 more than anybody should be willing to pay. Are the shares priced correctly? No. They are way too expensive. They are overpriced. They're sold for $80 while their true value is only $75. So they're $5 overpriced. By the way, technically, we can use the financial calculator for perpetuity problems, although you're probably realizing it's not worth it because it's a very simple formula. You can do it by hand in just a few seconds. But okay, let's say you're curious. Can it be done in the financial calculator? Yes. Because a perpetuity is like an annuity with endless cash flows. For your N, put a few nines, like 999, 999. I think if you put way too many nines, it will get confused and give you an error message. So put 3 nines, it's good enough. Or, because we are solving for perpetuity present value, which is like the present value of an annuity with many payments, you can also use cash flow keys, like we learned for present values of multiple cash flows. Again, here where it asks you for the frequency of your $3 cash flow, put a few nines. 3 nines should be good enough. Put 999, and then when you find the net present value, it will give you pretty much $75. So you might be off by a couple of cents. Actually, let's try that. Let's try using the annuity keys. Let's clear everything. Second, plus, minus, enter. Let's actually increase the decimal places just to get an idea how far off we will be because of the rounding error. And why is there going to be a rounding error? Because technically n is not 999, it's infinity. But 999 is a good approximation. So let's see how far off we will be. Let's increase the decimal places. Second decimal place, let's make it 7. Enter. Our payment is $3 every year forever. 3, make it negative, press PMT. 4 is the interest rate per year, 4 IY. For our N, we're gonna put 3 nines, 999, 999. N, compute, present value. See, we basically get $75 and 0, after the decimal place up to 1, 2, 3, 4, 5, 6, 7 decimal places. So probably in, a much higher order decimal place, we are going to see something other than 0. But, you can see how 999 for infinity approximation is perfect. Now let's instead try the cash flow keys. Let's clear everything. Let's again increase the decimal places. Second decimal place, let's make it 7. Enter. Cash flow keys. You start by pressing the cash flow button, CF. You don't get $3 paid to you right away, so you save cash flow for times 0 as $0. Enter. Down. Cash flow number 1 in the future. That's your first $3 dividend that will be paid to you. You press 3, enter, down. Now it asks for the frequency. How many times in a row are we going to have the $3 amount? The default is 1. We need to change it to technically infinity, but I'm going to prove you that putting just some large enough number will be fine. Let's put 999. Enter, down. NPV, the interest rate per year is 4%. 4, enter, down, compute. Again, we get basically $75 even. Technically, you would see numbers other than 0 somewhere in higher order decimal places, but in the first 7 decimal places, it's a 0. So it's perfect. 999 could be used, in place of infinity if you want to, use the financial calculator whenever you can, including perpetuities. My suggestion would be, just stick to the formula. Do it by hand. I think it's a lot faster. Next example. You just paid $750,000 for a financial security that will pay you and your heirs $42,000 a year forever. What rate of return are you earning on this policy? The word forever should right away tell you that we are working with the perpetuity. You just paid $750,000. It happened now, so that's the present value. This is the present value. We already know what it is. $42,000 is something that will be paid a year, right? So repeating every year, forever. So that's the perpetuity payment. Right? So we have the present value of the perpetuity equals the perpetuity cash flow divided by the interest rate R. We are given the perpetuity present value and we are given the cash flow amount. So what we need to solve for is the rate of return. We need to rearrange this little formula to solve for R. We can solve for the interest rate by dividing the perpetuity payment by the present value of a perpetuity. So we have just rearranged the present value of a perpetuity formula, which is C divided by R, to solve for R. R equals C divided by present value of a perpetuity. And then we just plug in the numbers that we are given. There are only 2 numbers that we need to solve for the perpetuity interest rate. 42,000 divided by 750,000, which gives 5.6%. So that's the annual interest rate. In general, there are only 3 things that could be required to be solved for in a perpetuity problem. Either we find the present value, which is C divided by R, or we know the present value and we know the perpetuity payment, like in the last example, and we are asked to solve for the interest rate R, or we know the interest rate R, we know the perpetuity present value, and instead we are asked to solve for the perpetuity payment. C equals PV multiplied by R. So these 3 formulas are actually the same one formula, just rearranged differently. It's really the same one formula.